Unit 4, Motion Control, Mobile Robot Part 1, Model Plan Act Approach. Adjective, Mobile Robot, Model Plan Action Approach. So in this lab, we will be focused on the deliberative approach for design control. It is also called as Model Plan and Action Approach. Control system for mobile robots. Build a control system for a mobile robot can be very challenging because you need the knowledge about mechanical engineering, electrical engineering, and computer engineering. Your control system must integrate these components so that the robots can achieve the desired goal. And mobile robots are very complex and involve many interacting components, and you need to put them together to act as what you wanted. Building the control system for a mobile robot can be very challenging. Just as you must carefully design your robot chassis, you must carefully design your robot control system. And in fact, robot control system is more difficult than the robot chassis. So how will you debug and test your robot? There's a testing problem. What are the performance requirements? Can you meet it or not? Can you easily improve aspects of your robot functionality? Can you easily integrate a few functionality and put them together to work as a whole? So basic primitive of a control system is behavior, so the action. So behavior should be well-defined, self-contained, and independently testable. So we have an action called turn right 90 degrees. We have action called capture a ball. We have an action called go forward until reach an obstacle. We have action called explore playing field. And these are actually the action for this Pac-Man. So let's assume that Pac-Man is actually a robot. So these are the different action name or the behavioral name. So basically these are routines, these are functions, these are methods that you need to design in your control system. Key objective to compose behavior so as to achieve the desired goal. So for example, you are going through a maze and you need to use those behavior to achieve the goal. And we can use the behavioral approach, and or we can actually using this so-called plan model approach. So here there are different things, but first we need to understand what are the actions or behaviors. So what is the model plan X approach? Here we will talk about this first approach. So model plan X approach basically is a sensor, plan, and actuator approach. It is a serial design, but the planning stage we actually divide it into model, plan, and act 3 steps. So step 1, use the sensor data to create the model of the world. So basically, you're watching the environment. For example, you're Pac-Man, you're moving and you watch, and you will see where will be the obstacle and where will be the road you can move on. Okay, as it moves, you will have different angle that he can see. But based on what he see, he need to build a model of the world. And then use the model of the world to form a sequence of behaviors that you can do. So basically, you accumulate data by the sensor and you are making up a map. So originally, based on your visibility, you may only cover this corner. But because you're moving on it and your model actually will grow. And then based on the model you grow, you take different behaviors. So we have 4 behaviors as we described before. And those behavior will be the action you will take. And after you take the action, and one of the action is turn 90 degrees. You turn 90 degrees, you'll see different things, and you will update your model, and you will plan, and you will take another action, and then you will actually do different things over there. So let's go back to our actions. So it has different behaviors, and every time you work on a behavior, then you move on, you change the environment. And the environment change, the model of the world change, and you plan on taking different action, and you make a decision and choose the action, and you move on. and the environment got changed. So reform this cycle, and you actually have use the sensor data to create a model of the world, and then you actually try to achieve the goal and you skew the plan. So here is an example. For example, the red dot is your Pac-Man, the mobile robot gets started. And then at the beginning, you have such a view angle, so you need to model your wall as this. There are certain walls you will actually need to mark. So you basically see this different thing and you see the wall like this. These are the walls you actually see at this moment. And based on your view angle at most, you can only see up to here. And then you move to this point and choose action toward here. And you have more view angle. So based on this point, you should be able to see further away. And you will see something that is based on your view angle, you should see something that is. So next one, you may actually choose to move to here, here, or here. You need to make decision. But you need to also remember where you are. So here is point A, point B, and you can choose point C, D, or E. But because you can put them into a stack or a array list, so you are actually moving from A to B. Now you are making more decisions at this point. So that's as soon that you actually will make some decision, you move on to your E point. So you move on to your E point, and in your stack, you put the E over there, and you actually take the route and go to here. So at this point, you actually will see this one and see this one, and also the gate. And I think that at this moment, you are able to go to the gate because it's closer to everybody, and you don't need to move further. And you can move to this point, that's also okay. And that actually finish it. So basically, transforming the world into the so-called convex system. So you actually can see something like this. These are the world that you will see, and you can dissect them into convex cells. So convex cells are these. The so-called convex cell, this is one cell. The so-called convex cell, actually, this is a convex cell. This is not a convex cell. So for example, the previous view, what you see actually here, the first view you see is over here. So actually you will see something like this, but it's not convex because you will have an angle like this. That's not convex. So you dissect that into here, that is a convex. So you divide the region into different convex cells, and then you can move from here to here, and you will see different angle. And this is one more convex cell, okay? Here, this one's another convex cell by the section. So you divide your movement space into different convex cells, and then you make plane like this. There are different points that you can move on. These are the so-called midpoint. So the so-called midpoint calculated based on this point and this point, you have a midpoint. This point and this point, you have a midpoint. And also this point, and actually, let's see, this point to this point is a midpoint. And then from this point to this point, you have a midpoint over here, something like that. And based on those different midpoints, you actually can have the central node and get a map of all possible paths. And these are the paths you can move on. And based on the paths, you calculate the shortest path to the gate. And you will figure out at least. And it can be optimized by actually decompose the different route. So midpoint finish, and then you can actually add more point to actually decompose the cells. So advantage and disadvantage of the model plane X approach. Advantage: global knowledge in the model enable optimization, can make provable guarantees the plane. And disadvantage: much implement functional unit before any testing, computationally intensive, require very good sensor data for accurate model, and model are inherently an approximation. It won't be optimal, and work poorly in dynamic environment. So if people change the maze, you cannot solve it. And usually this model plan X approach will be used when you make the first model, complete model. So basically you use your mouse to explore the world once. You may make mistake, and it explore the world and it construct the whole map. And after it is finished, you actually can find a better route and reach the destination faster. So it is actually constructing the graph first and then you optimize it later. So this is the so-called model plan X approach for control design. And it is an algorithm, and we implement the algorithm and find the processor to deal with this algorithm. Thank you. Bye now.